Hello, everyone. Good morning, good afternoon, good evening, wherever you are. My name is Damilola Ige, and welcome to this introductory course, this introductory session to object-oriented programming. Basically, we'll be looking at object-oriented programming basics, for both back end and front end. Though we most likely will be doing most of the coding in PHP, but I can assure you that most of these are so relatable to what we have on the front end as well. And if we are able to have another class, I think we're able to do some in JavaScript if time permits. So you're welcome. So let's just get into it. So when we say object-oriented programming, which is a programming paradigm that uses objects to design applications and computer programs. So
It's 10 hours.
it provides a clear modular structure for programs, making it good for defining abstract data types. So like it is a programming shift. That uses objects. Now it helps to actually have a clear modular structure for programs. Like it makes sure that we have easily readable code, and it ensures a clear structure for your code. That's basically what object-oriented programming does. So there is a class structure, there is a clear path, there is a modular arrangement for your program in such a way that it's easy to make changes. It's easy to come back to, and you're like, okay, this is the part that I want to make changes to. So if you say object-oriented programming, so what is an object? And let us look at it. If it's object-oriented, what exactly is an object? So we define an object as a thing from the real world, like anything in the real world, anything at all that you want to represent in your software application. You want to represent a person, an animal, a car, whatever it is, be it a book, a library, anything that you can think of that is an object that you want to use in your programming language, that is what we call an object. So anything is an object. A string, an array, let's not come to programming, a class, those are all objects. So anything that you can imagine, anything from the world that you can use in your software application. And usually we say a class is an object, and instances of class majorly are objects. So we can say an object is an instance of a class that contains data. Some people always would like to use that definition, because when you create several objects from classes, so it contains data, which are attributes or properties, and behaviors, which are methods or operations. So for each of the class, because we will still be looking at a class, but we know that objects contain data and attributes, like they contain data and behavior rather. So they contain data and they have behavior. So for the data, we could also those data are called properties or attributes, and the behaviors are like the methods or operations guiding the object. Some objects are also referred to, so people also refer to objects as an entity. So not to take too much of our time, we look at what is a class. A class is a template or a blueprint. So something that you know that you can use in creating other objects. So that's just a class. A class is just a template. So it defines the attributes, which are the fields or properties. We talked about the an object having data. So that data is the attributes or the fields or the properties. So some people call it fields of a class, some people call it properties of the class, some people call it attributes of the class. So a class defines the attributes and properties of the object, and then defines the operations which we call behaviors earlier, or the methods that an object can have. So let us quickly dive into an example. Let's say we are looking at a person object. Now if I say a person class, what are the properties that a person class can have? So let's say I'm doing class person. What are um sorry, I have, let me just, so let's say I have class person. I have some but because of, so we have class person, and basically what are the attributes that we expect of a person? We expect that a person will have a name, a person will have an age, a person will have a gender. So basically I can actually accept what is being given to me, but we can add more to it. I can add more to it. Before we continue, we have name, age, gender. So this gender will be equal to gender. And then we also have that, because this PHP, we definitely need this to have a semicolon. Oh, sorry. So why do we have this here? Oh, okay. This is not yet done. So, alright. So we have these are properties. We can have some other properties. I can decide to know, I might want to know the email of the person. You might want to know the username. You might want to know the date of birth. Those are properties. Password, date of birth, a lot of different properties that you can, decide to have. We saw like a list that we can have, and it depends on the kind of person you're also describing. I might want to know is admin, is a user or something. There are like different attributes that, like for example, here we have an attribute is alive. True. Not like this person is alive. You can have like his admin. You can have like his employee or his director. Something different depending on what you. So properties of an object are just attributes, or those things that describe how a class looks like, or those things that describe a class, or those things that describe an object. I will just limit this to just what we have, but just know that we can have this as properties. I will leave that. And then for the constructor, a constructor is just like, okay, if I'm creating an instance of this class, then what are those things that I must provide? So it means that if I'm creating an instance of this class, I have to provide the name, the age, and gender to instantiate the class. So that's what the constructor is doing here. And then we have I can even add the is alive. We can also have methods that we can declare for this person. So let's just look at methods. So you can see public get age or something. So for example, this is a method. So it should be public function. So this is a method, for example, to return a person's age. There are a lot of, I can say, for a person, normally, what are the actions or what are the behaviors? So the behaviors that you would expect is greets. That people greet each other. So something like this, something function greet. That people actually do eat. This definitely is listening to what I'm saying at this point. So we have, like different methods here. So we have public function greet, public function eat, public function get age, and all of that. So there are like different methods that you can public function sleep. You can, those are just like behavior. They are just methods describing how a user, or how a person, describing a person. So without much ado, let's create an instance of a person. So we have some recommendations here already. I will just accept that because of time. So let's say this is a male, and then we are trying to, for example, person. No, let's call out echo person one greet. Now we will expect that this should be called. So so echo person one greet. Now because it's PHP, let's try to run our OOP intro .php, and running it, you see what is in the. I'm not sure if I'm able to. Okay, make the, yeah, that's possible. So I hope the terminal is as big enough for you guys to see. So you can see that here we have my name is hello, my name is John, and that is just what we ask it to uh, you know, output to the console here. When we call the greet function, it should say my name is John. If I call the eat function, for example, then we should have the other. So if I do, so this is basically just so that we can ensure that we have it on the new line. So if I say eat, I'll also try to tell it to echo the age. So let's run the function. Let's run the file again. So if I run the file again, actually, so it says my name is John. John is 18, and I am 25 years old. Let us try to change this. So let's do this name is this name is so that's a dot there. This name is this. Then we have, yes, so thank you. So we have that, and this name is this yes, and that's let me see what it's complaining about. Okay, return time. So we have that, and visually this should go on a new line. If it's not actually going on a new line, then we can, instead of the break, we can have all right. So let's run this again, and then okay, I'll try to clear the console so that we have, yeah. So we have John is 18. John is 25 years old. Uh, okay, hello, my name is John. John is 18. John is 25 years old, and we have that. We have I don't know why it's actually. Let me clear this place, and I actually want this to be well constructed. So my name is, sorry, there should be John is, so yeah, there should be a space here. Yeah, so we have that. So let's run this again, just so that we have, yes, it's well constructed. And so, hello, my name is John. John is 25 years old. I'm just sorry. Those are just like little things when you are programming, just ensuring that this output very well, and we can see what we are trying to do. So this is basically the nitty-gritty of object-oriented programming. We created a class, we instantiated the properties of the class, and we are good to go. For I can actually set other properties. Immediately I created it. For example, remember that we declared the email, we declared the username. I can actually have that. Oh, sorry. And then I believe I have username, something like that. John Doe. Password is alive. I can just leave it alive as it is. And I can try to echo these things so that we can have echo. Yes, username. So let's run our program again. I'll play this console and let's have this. So you realize that even though I did not initiate them in the constructor, so just to let you understand what the constructor is for. So constructor, it helps us in initializing some things that matter. Like you just want to ensure that these things they must be included when I'm creating this person. So if I'm creating this person, I want to have the ability to be able to have these properties initialized along with the instantiation. So that's why we have the constructor, but it is not a must that it has to be there. If you want to declare your class without a constructor, that's absolutely fine. What that just means is that you will not be able to initiate or instantiate your class with any properties, and that's also absolutely fine. But it's usually like common practice to just when you are instantiating a class or initiating a class to have those properties instantiated as well. You realize that the other properties that we did not include in the constructor are also added to that class after instantiation. And I believe I believe that you would have preferred having all of these added at the point of instantiating. Well, I prefer that most of the time. So that is basically us creating a class, creating an object, and getting the properties or what's it called now? The properties methods of an object, and a lot of different things can be done. Like I can actually have let's say I just want to show maybe some things that we do, like when you are filling a form online, for example, you want someone to log in and you are basically actually checking the password of that user, right? So let's say you have a function login user. You receive an email and the person's password. And when you receive that, you check if the email is equal to the email of the user and if the password is equal to the password of the user. And you return some things. And I just want to be sure that this is correct, what I actually want. Okay, so you are just returning. So if the email of the person is equal to the email entered, and if the password is equal to the password entered. So this is just like an example. It definitely gets much more complex than this when you are checking if a user is logging, but this is just like a pseudocode to show you how it works. And this is also like everywhere. This is majorly how you check if and usually in practice passwords are hashed, so passwords are not stored plainly in the database. So this is not like how you actually check for a password. Most of the time you on hash, like you decrypt the password or dehash the password, or check or try to use your hash function to see if the passwords match. I think those are, so we call the things I've been talking about. Let's just say we hash the password. So we hash the password. I'm just trying to put it that so you understand what I'm saying. Some people encrypt a password, a clean password. So we have, those are just, and if you want to check, you use like whatever method you used in hashing the password or encrypting the password to compare the password. So you don't actually do some things like this, and then so that's just like sharing that knowledge. So basically, if I want to log in a user, I have to supply. Let me clear this. So let's clear this. So if I call alright, I would love to have all of these and we have the username password. I'll leave them as it is. Now let's say I'm logging this, and then login user, I supply the email. The email is john@email.com. Then with password 123. Now this is what I expect to be correct, right? So let us try to use an email that is not here. That an email that we do not, the wrong email. So we are using the wrong email, but we still the correct password. So let's see what each of them will do. Let us just run our file again, and so for the first one, you are now logged in because we supplied the email of the person. But for the second one, you see your email password is incorrect because we supplied the wrong email. So just to like give an idea of how we might use these classes. So when it comes to object-oriented programming, we have like four concepts. There is the concept of encapsulation. There is abstraction. There is encapsulation. There is abstraction. There is inheritance, and there's polymorphism, and we'll try to like look at this. I'm not sure if we have because I want to make this video as short as possible so that it will bore us, and then we can go to like a part 2 of the video, and if possible a part 3. I just hope we can do it in 2 parts, basically. So I don't want it to be more than an hour. So let's see. So for four core concepts of object-oriented programming, we have encapsulation, we have inheritance. We have encapsulation, we have abstraction, we have inheritance, we have polymorphism. Now, each of them are unique in their own way. When you say encapsulation, it is hiding data and complexity. Like you hiding information. That's what classes, or that's what object-oriented programming helps us to achieve. So you hide data, you add complexity. There is information hiding. Then you have that you group together related variables and functions, and then you reduce complexity and increase reusability. That's what encapsulation helps us to achieve. And if you look at functional program, most of the time there are like some functions that you add as many parameters or arguments as possible, just so that you are able to use that function or use that function. If you want a function to be reusable, for example, you might see yourself adding so many parameters. I've seen functions that have as much as 6-7 parameters, and if you see that you are actually declaring a function with as many parameters as possible, then you need to I think at that point in time you will see that you need to like actually embrace object-oriented programming or just change that function into a class. If you are doing anything that is taking more than three parameters at all, it means that probably you need to encapsulate that in a class somewhere. And if you're actually using object-oriented programming and you are still seeing yourself having methods that are taking more than three parameters, then definitely something is wrong somewhere. That it definitely something is wrong somewhere. You shouldn't be object-oriented programming should be able to reduce parameters as much as possible, as much as possible. That's why I love the quote by Robert C. Martin. It says that the best functions are those with no parameters. The best functions are those with no parameters. So the fewer the number of parameters, the easier it is to use and reuse a function. So if you are using a function from a class, for example, you expect that that class has already encapsulates most of the complexities, encapsulate the data, the information that you need, and you are just calling that method from that class, to help you carry out some to help you carry out some of the things that that you need, or to help you carry out some of the functions or some of the operations you want to do. So for encapsulation, okay, that's encapsulation. So for abstraction is hiding details and complexity of an object and showing only what is essential. So encapsulation helps to reduce. So abstraction helps to reduce complexity. Abstraction gives us a simpler interface. Abstraction reduces the impact of a change. So when you abstract the complexity, the impact of change is reduced. What does that mean? That is, if you have to make any change anywhere in the program, the places where you have to make that change, they are not as, like, you don't need to do make changes in several places. Most of the time you have to make a change in just a particular place, and the impact of that change is reduced because you are only making that change in a place and you are not actually maybe adjusting several files or several modules. So that's what abstraction helps us to do. So it reduces complexity, it gives us a simpler interface. For inheritance, inheritance helps us to be able to derive other classes, from a particular class. Like you can derive a method and property from another class. So that's majorly inheritance. So like you have a class already and you want to create a similar class. You do not need to, like, let's say I have a person class and I want to now create an employee class. An employee is a person. So for an employee class, probably I saw that I would need the name, the email, username, and all of that. I wouldn't need to create that from scratch. I just need to inherit the person class and then continue with methods peculiar to the employee class. So that's basically what inheritance does. Like, it helps you to derive methods and properties from another class. So it eliminates redundant code. There is no need for you to repeat yourself. Like, there is this principle DRY in programming: do not repeat yourself. That it basically helps us to reduce DRY, to adhere to DRY rather. So there is also polymorphism. Polymorphism, that is many forms. Poly is many, and morphism is like form of something. So polymorphism is many forms, and that is, a class can implement an inherited method in its own way. That's what polymorphism is. That is an inherited method. So whatever it is, that helps us with inheritance. So inheritance polymorphism actually goes hand in hand in such a way that if you actually inherit properties and methods of a class, you can actually do those methods in the way you want. So even though I have login user for a person class, and I want login user to do something else, or probably to carry extra checks for an employee, I can adapt login user to that employee class in a different way. We would see examples with something else here. So what I have for me is we have a bank account class. I have a bank account program that I have created already, which is in procedural programming. So I have to increase. So, let me increase this to a point that, yeah, I think this is fine. So we have this bank account file. It has most of it's a program that just creates a bank account for users. We'll be trying as much as possible to recreate this program in object-oriented programming. This program, as it is in functional programming, procedural programming. As you can see, we have a bank account, what's it called, array, where you have the balance property, the transactions, which is also an array. Then we have the function create account, which takes in an account parameter and initial balance. And this is just to show that so it's void account balance, initial balance. It just echoes the account created. It's just a simple bank account program that just helps us to create, like that imitates the basic things you would do when you are creating when operating a bank account. When operating a bank account, and before we
It's
actually
10:30.
work on it, so please ignore my my timekeeper. I have that set on my system, and I don't want to go and be putting that off when I started the video. But at least because by 11 o'clock it will also give an alarm, so just ignore that, please. So we have the different functions that you will see when you are relating to a bank account, creating an account, depositing money, withdrawing money, and then checking the balance. Then there are like helper functions. We also have like something that adds transactions so that we can print transaction history, and then there is a function that helps with user interaction. So this, you can actually interact with this on the terminal. You can interact with this on terminal. So I created all of this so that we can just see how it works. So let us see what we are getting into. Basically, I want to put this into full screen. Probably if I do that, you guys will not see me for some time any longer. So I'll put this full screen. Yeah. So I will clear the terminal and run this file, so we see what we are doing. So let's say PHP bank account underscore PHP. Sorry, bank account dot PHP. So account created, and that's just what I have here. Create account, create bank account, and then with a balance of 1,000. So it says account created with balance 1,000. You create an account with initial balance. So and that's what this does basically. So it creates the initial balance, and then we have the user menu. We are calling the user menu this user menu, and this user menu is what we have here. So we have check balance, deposit money, withdraw money, print transaction history, and exit. Now apparently you don't have any transactions yet, so there is nothing to print yet. If you want to check balance, you can just provide one as an option. You enter that and it gives you that the current balance is 1,000. If you want to deposit money, you can just press 2, and then it asks you to deposit an amount. So let's say we deposit, I'm a rich person, I'm depositing $100,000. So it has deposited 100,000. Let's see the balance to see if that actually works. So put in 1, and you see that we have 101,000, as our balance. So if I want to withdraw money, let that option to withdraw money is 3. So it will ask me the withdraw amount. I just need a few bucks, So I withdrew 10,000. Let's check balance again. One, it shows that it has removed 10,000 from it, so 91,000. So this works perfectly, in function programming. You can also, let's put transaction history. So transaction history, you see you deposited 100,000, withdrew 10,000. It shows you the history with the date and timestamp. Yeah, so that works as expected, I believe. And if I want to exit, I just click 5 and that's it. It exits the program majorly. So we have something that works there, right? But we want to now explain most of what we have been looking at in object-oriented programming in so whatever it is that is there, do not bother yourself with it. Just let us look at the principles of object-oriented programming by trying to transform this procedural program, right? So we'll create a new file. So I'll create a new file. Let's say bank account OOP. .php. And yeah, so I want them to be side by side. Okay. So these two, let me increase our font here. Yeah, so we have for bank account.php, we want to like see the OOP in object-oriented programming. So for let's try to start the factoring it. So we have this is all of this is about a bank account, the user's bank account. I think it is just fine. I think it's just all right to create this as a bank account class. So let's say class bank account with uh, properties that are balanced, and then with transactions, those are properties as well. So those are like the major property, the balance of the account and the transactions, those are the properties. Then we have that we create account. So if you are creating an account, you don't need to have a create account. That will just be your constructor. Remember that if you want to actually add anything when you are instantiating an object, you can define that in your constructor. So I'm trying to like let us know how this would go when it comes to uh, when it comes to like refactoring this. So let's start. So we have class bank account. Pardon me. Class bank account, and then we have private. Probably it's going to be private property. So it's showing float, what I'm not going to. Yeah, private balance, and then the transactions, just showing the type of, and then we create the constructor, and basically these I'm accepting all of those recommendations because of it saves time, and that's what AI is just awesome. I hope those that are not embracing AI, I hope they have a change of heart, because it's basically just makes your work easier and makes it faster. Imagine having to type all of that all over again or something. It's not just what you want. So we have that float, initial balance, just as long as you know what you are doing. Basically, yeah, you are not just accepting the AI client sync. You also need to be sure what you are doing. All right, so we have here float, the balance, because the type is float. I just left it as that. It's definitely not going to be an integer. You are going to have balances that would be maybe in cents or kobo or in pence, like depending on the currency you are talking about. But I would not want to complicate our program with currency. If not, I would have actually included a currency type, somewhere there. So we have private float balance, private array transactions. It shows that those are like I said, those are like our properties. Then we have initializing this. When you are creating a bank account, you can just create it at the instantiation of your class. So you add your balance, and then you have that the balance is the initial balance at least, and then transactions will just be an array, an empty array at the start of when you are initializing your class. So you have account created with balance, blah blah blah. That's perfect. That, like, you got that perfectly. But we also have other methods here. We have the deposits, and basically all of these are the same thing. The only thing we are not going to add here is we do not need this account, because this account is already part of what's good. This account is already part of the properties. So even if you're adding transactions, we are the add transaction is already taking care of that. That's one of the things I was mentioning about abstraction, helping us about encapsulation, helping us to reduce the parameters. So yeah, we do not need to add the account parameter any longer, because that is being taken care of by the class. So remember that we need this add transaction method in the class. So if we need the add transaction method in the class, we need the validate amount method in the class. So let us first go and take care of those. Then we'll come back to because those are like helper functions majorly. So for validate amounts, we have validate amount here, and we can just copy it as it is and just bring it here. So the validate amount, since it's, let's say it's private, so it's here. So private function validate amount, then it takes the amount, and it definitely returns a boolean. That's what this means. It returns a boolean. So it returns if the amount is numeric and amount is greater than zero. Basically the same thing that we have. And the only thing that we have to add here is this modifier. So we just added this so that we are not calling validate amount outside this class. That is the meaning of the private and the public. So they help us to ensure that these properties cannot be used outside of the class. That's what these private and public modifiers that you are seeing, that's what they are doing. So they are ensuring that it is a private method. It is only used within the class. It can't be called outside of the class. So even if I instantiate an instance of bank accounts, I cannot call validate amounts on that instance. That's just what it means. I can only use validate amount within the class. So any other function that I create within this class can call validate amount, but we cannot use it outside the class. That is what private does. Then like we mentioned, we also need add transaction. So add transaction also helps us to add the transactions, and because we are calling transactions and some things you have to change, remember that we do not have like an account property any longer. So our transaction will remove the account, and when I'll just copy this and I'll make that change when I after copying. So function to add the transaction to transaction history. I'll make it a private function as well. Now this looks fine, like okay, but again we do not have the account. Remember that there is no account property and there is no account method any longer. So because of that, we are actually referring to the what's it called, to transactions I read directly. So these transactions, so it is not just, it's no longer the transaction property under account like we have in procedural programming here. It is now the transactions property in this class. So which means that this first parameter is gone. So removing that parameter, I'll just come here and have these transactions. So that is the transactions property in this class. And you know that it's an array. And that is how, so it's calling these transactions and then of type, amount, and then date. And that's how we add the transactions. So we have the private add transactions, private function add transactions, and then okay, okay, sorry, the because I copied the comment here, this should be private function. Yes, okay. So we have that here. Now that we have those two functions, we can now copy our deposits function from here. So and I'll still give it a. Now we are going to be, if you look at it, when you are depositing money in you would definitely want them to interact with your deposit function, so it can be private, so it will be public. So wherever you are calling deposit, you call deposit from outside the function, out from outside the class most likely. So it's going to be public function deposit. We do not need this first parameter any longer. So you understand what I mean when I say our parameters are going to be reduced as much as possible. So public function deposit amount, and the balance is a property, no longer part of account. So it should be this balance plus equals amount. And then we have the transaction also. It is we are referring to the transaction property, so it should be this transaction. And if you are referring to transaction property, there is no account parameter any longer. So we have deposits and amounts, and then yeah, I believe we have been able to handle that for this class. Yeah, so for this class we have, if I go to add transactions, so transaction is type and amount, and then we've actually added that. So yeah, so the validate amount also, that we did not need to do any other thing there. So we have the public function deposit. Then let's handle withdrawal too. So for withdrawal, we copy what we have here, the function to withdraw money. We are just trying to make this in a class, so we are using object-oriented programming as much as possible. So public function withdraw, and since we are withdrawing, we do not need this. If we do not need that, then if validate amount and amount is less than or equal to balance, this balance, so that takes care of this. Then it means that the balance we subtract. So this validation that you are doing here is basically trying to, like, does the user have enough money in their account, and this balance minus equals amount. Then the add transaction too. Remember that transaction is a what's it called? And oh, pardon me. This validate amount is a method of the bank account class, so it should be referring to the class. So we have this validate amount. So we have that, and then you should also be doing same for yeah. So I don't know if we needed that. I don't, if you are seeing unexpected identifier, um, public function deposit amount. Then we have if this validate amount is this balance plus equals amount this transaction deposit amount, then you echo deposited, then deposit is amount, and that's echo invalid deposit amount, and yeah, and that's all. Then we have public. Oh, sorry, I don't get what it means here. All right, so and so this it was because of this identifier. So public, yeah, there was a mistake there, right? So it wasn't about the return type. So let's just have this. It's just good practice to have a return type, especially from PHP 8, I think. Yeah. So we have this for and validate amount here should also be referring to the instance of validate amount in this class. And then if amount is less than, so if the amount, so basically we are checking if the amount is valid, and when we are checking if the amount is valid, remember that we're just basically looking at, is this amount greater than 0, and is it a number? That's what we have. So if it's a number and amount is greater than 0, that's what we are validating there. Then even when you are trying to withdraw, we are now checking if you actually have enough money in your account. How do I check if you have enough money in your account? Is the amount you want to withdraw less than your balance or equal to your balance? So that's basically that check. And then after you have withdraw, you have to subtract that amount from the balance. Then this should be calling the instance. So these are transactions, and if you are doing that, account is no longer a property that we are looking, that should be there. So and then we will do this. So I believe yeah, we are still on track. So we look at check balance. Check balance basically do not need this any longer. So see how this is going to change. We do not even need any parameter for check balance. So for check balance, you have public function check balance, and remove the parameter, and what is it returning is returns this balance, and that's all. So we've removed and for us to print transaction history, we are printing transaction history. We come here, so function to print transaction history. So we have public function print transaction history, and it should be if empty these transactions. It will not take any parameter. There is no need for us to take any account parameter. So it's if empty. I think we have this. So if empty these transactions, and then no transactions found, and you go to the next line, return. Then if there are transactions, then definitely this will be skipped, and it comes here. So it loops through all the transactions that we have. It looks all the transactions. So we have that this transaction for each transaction, then it echoes transaction day, transaction time, transaction amount. So basically just printing out that. I believe we are still on track, yes. So we have that for the printing of transaction history, and that's basically it for our uh, back account class. So our bank account class, we were able to handle all of the bank account class in less lines of code, which makes it more readable. Like compared to functional programming, yeah, we had like 74 lines. Yeah, that you might like, okay, that's just 5 line difference, but that is actually it's something significant. It's also important to also look at compare the number of parameters that we have removed, and the fact that there are a lot of methods that we can just call upon. So basically, what we have done here, we have actually handled both abstraction and encapsulation, based on this refactoring. So based on this refactoring, we have been able to uh, organize it better. You have group related data for unlike what we have here, where we just have like functions, different functions everywhere. Like they were not see you don't see them as a group. You don't see them as a group. And for if you want to reuse, it's probably you'll be calling those functions individually. But on this particular page, we on for the bank account class, we have that all of them are compact. We have them organized, and they are inside a single bank account class. We are able to encapsulate data, so we use the private properties and methods. There is control about how data can be accessed. So the things that do not need to be accessed, they are not we do not need to access them. And then we also ensure there is modularity, reusability. How is it reusable? I can use the bank account class anywhere in my program. If I want to use it in other parts of the program or in different programs without modification, I can just carry the bank account class as it is, and just export it elsewhere. So because I want us to learn this so that we can see that it's basically doing the same thing, I will have that bank account class as it is, and then still bring this function, uh, this user menu function. So okay, how the user menu function and bring it here. So the user menu function is not part of the bank account class. So the user menu function is just on its own, and no, we won't have a global bank account, so we are not using that. So what this means is that we are going to be adding a instead of bank account, we are going to be adding the account as a parameter, because this is no longer, so the user menu will now be on its own, and therefore is not unlike here where we have the bank account as a global property. Here we do not have that, so we can add an account or the bank account as a parameter to user menu, and this is not necessary any longer. Okay. Oh, sorry. Yeah. So I think when I was trying to remove that, and then you have the user menu, and then I have this say duplicated code fragment, blah blah blah. But that will be I'll be looking at all those ones later. I think I'm trying as much as possible to reduce our time to just an hour, maybe a few minutes later, but at least you have that. So for the bank accounts, so we have that for each of them, we will make some changes. For example, we want to check balance. Now, because the account, we have to pass the account as what's it called? As a function to bank account. So what we are going to be doing is let's have the bank account. So if you are going to be checking balance, remember that check balance is now a method in bank account. So what I can do is so that we know what type of method bank account is, I'll just say it's of type bank account. And that's another thing we can do. We can actually make let me see what it's saying there. Like classes can actually serve as types, but just give me a minute, let me understand some what's happening here. Expected, we have that. Okay, I think I've
It's 11 hours.
yeah, okay. Sorry, I was doing I saw what we I did wrong. So I was adding that type the way I would do in JavaScript. If you are working with so many different so it will be bank account check balance because you are trying to check balance. So for the fact that I was able to add this bank account type, so I was saying you can add classes as data types. So apart from the fact that classes helps us to organize code, object-oriented programming, we also can use them as to provide strong type to our programming, which makes it easy to be able to what's it called access properties of parameters. So if I did not add this back account property type, let me just show what will happen to this parameter. Let's say I did not type this and then I want to pick up like you want to deposit an amount, and definitely you want to get the deposit property of bank account. So what you'll be doing here is you'll be doing bank account uh, then you will realize that we did not get any suggestions like the way we had for check balance. I will show this suggestion is coming from AI. It is not coming from the fact that it's seeing it as a type. AI already understand what I'm trying to do, but the program itself is not seeing bank account as any particular type. So it is not bringing the all properties or the methods in that particular bank account. If I go back and add the bank account class as a type to bank account, this changes entirely. So let's have this. You realize that I have deposit. Well, AI has taken over what I should be seeing, but it should just have that, and then I do not need this deposit amount or whatever. That particular method is not needed. So we have like bank account deposit. So we have that, but if you point towards this, you will see now that it's saying that bank account is what a method under what it represents the bank account class. So it's like the bank account parameter represents the bank account class, and it's class bank account. You can see that, so at least you know the type. Before that, when I did add this, it didn't see that there. So that's just for you to like get used to typing, and then I'll just accept this because of time. This is longer needed. We do not need this withdrawal method any longer. Then pre-transaction history is also from the class. So we have bank account pre-transaction history. That method, okay, I think we are done with that. So those are like public methods that we have. So we drop deposits and then check back the bank balance, and I think that is all. Yeah, so for the user menu. So how do we use this compared to the other one? When you want to create a bank account, you can just create a new bank account. So initial balance is that, and then I'll just call the user menu and pass the bank account as a parameter in that. So let us try to call this. So if we work on that, so remember that the new file is oop.php. So it creates a new account balance for us with 1,000, basically what we have with the previous one. And then we can check balance, though you still have your 1,000, current balance is 1,000, which means all is fine. Let us try to deposit money. Choose an amount. Let's choose 100,000 like before. I've deposited 100,000. Enter deposit amount, deposit 100,000. If you check balance again, our balance is now 101,000. Let us try to withdraw amount. Let's make it 10,000. So we drew 10,000. So let's check balance again. We have 91,000. Though this can be improved, we can actually show the balance after every transaction. I think that would have been a better way, but that is left for you to improve upon, because we'll be having assignments. I'll try to push this to probably to GitHub, to a Git repo, and then provide that repo so that you guys can work on it, and we can have some assignments posted on the Zuri platform. Now, so we have all of this working. So let's see transaction history, and you can have the transactions that we've worked on. So that is where we'll stop today. The next video will be looking at other refactoring that we can do to this bank account, and at least probably what's it called, explain further, probably encapsulation, use getters and setters, try to explain inheritance. Let's see if we are able to do that in some ways. We will have to make some modification in some ways to the program. Then we'll look at polymorphism as well, which will also ensure that we'll make some modifications just to get that across. But that will be it for now. Thank you so much for having me. Bye.